Friends, good morning. And today we are going to talk on uh, industrial applications of microcontroller. Okay, and we'll be talking mainly on the food sustainability technologies, and I'll show you how we can take use of embedded systems and microcontrollers in various applications, very important applications such as food sustainability. There are a number of applications like you can have energy sustainability, food sustainability, water sustainability, and many other applications in the real world. One of the important aspect is food sustainability, because we can almost do everything like launching of satellites, missiles, all the sophisticated technologies. But at the end of the day, what matters is that we all should get the food. And unless we get the food and water, which is essential part of our life, we cannot do anything. So these are the important energy sources. So these are the energy sources for our survival. And what is happening is recently that the resources, our critical resources of the country or the world, they are depleting each day passing. And the challenge still remains that how do we feed our ever increasing population. For your information, like the world population is going to be 9 billion by 2050. So the biggest challenge is food sustainability. And sustainability also includes like having a food, quality food, safe food, and sustainable food. So enough amount of the food available, and that to safe food. It's not that it is contaminated or something like that, and it should be available on continuous basis. So there are basically, when we talk of sustainability, there are three P's, three pillars of the sustainability. People should get the nutritious food, and while in the process of getting the nutritious food, we should not be damaging the planet, that is ecology. Like we go on doing farming in a manner that it is damaging the soil, or it is damaging, we are spreading the pesticides in a manner that we are damaging the ecology, and we are applying the nutrients and fertilization to the extent that we are damaging the water table depths and it is getting contaminated. So the point is, without damaging the ecology, we should be serving the nutritious food to the people, enough quality and a good quantity, enough quantity and the good quality. And the one who is doing this all is a farmer, and therefore farmer should be getting a profitability to do this all, because if he is not getting profits and his livelihood is not increased to a good quality, if he is not making a good money, he will not be able to give us good quality and quantity of the food. So obviously what he is doing, is actually, if I now talk about the present scenario, what the present community is doing, after especially this green revolution in India, is that they are applying the rampant fertilization and pesticides to the fields for getting the better productivity of the food. But in the process that we are damaging the ecology, and the kind of food that we are eating, we all can imagine, it is fully infected with the pesticides and infested with the fertilization and etc., trace metals, etc. And that is further leading. So it has reached to the extent that the whole food chain system got contaminated. It's corrupted, and it is reaching to our blood and our body. And in Punjab kind of region, there is the Malwa region wherein the cancerous belts have been developed because these trace metals are passing to the human body. So these are the all repercussions which are happening. So the solution to everything is actually the technology. So how technology helps and serves the purpose, that is what we are going to see today. And I think I have started directly with the topic, but I don't know if you'd like to see one or two examples of the developing the embedded systems. But I'll just slightly touch upon the aspects that what are the important considerations when we talk of developing such industrial applications or real world applications which uses the embedded system. So what are the important efficient considerations which, as an embedded system engineer or an electronics engineer or a mechatronics engineer, should be considering or taking into account? So let me give you a little brief on this. highlights of the important considerations that one should be making. So, you know, developing a system is not only enough. You have to develop the system in a very efficient manner. And there are various software and hardware considerations that comes into picture, into play when we talk of developing an efficient embedded systems. And this includes number of points, various considerations, which we'll see in my slide. Uh, I'll begin with the slide which shows the important considerations while developing your real-world applications or industrial applications for that matter. And the industrial applications, real-world applications we'll be seeing today concerns to the food sustainability. We have already covered these basics controllers, microcontrollers, what they are and how they look like, and we have covered the story of this. Basically, we have seen because while you develop any embedded application, you have to consider cumbersome and not that hassle free. So people were not also convenient with that kind of option, because that also had some kind of impact on the complete development cycle and the productivity of the development issues. So Philips came, and the Philips launched P80 P89C51 RD2. So 89 again represents the flash series, but then RD2 had an important thing was in system programming and in application programming. And I talked on that day what is that in system programming means and in application programming means. Because in system is like without removing, you can simply program and see whether it is correct or not correct. And in application programming, that you can update the codes. So later on, similarly, the story is there for every other manufacturer. Like if I talk about the Silicon Labs, then they thought, okay, real world is analog, and therefore there should be a core which is a mixed signal. So Silicon Labs came up with the mixed signal core C8051, F120, 020, 350, different versions they have, and they launched the important the core of it was a mixed signal controllers. That means everything is on chip, analog and digital both. Same is the story with some other manufacturer like Analog Devices or Dallas. Dallas came up with the RTC and E-square PROM and various other feature. And Dallas also came with a kind of thing like so they increased some performance also. Talking about PEAK, that they discussed in details what is the PEAK. PEAK, there is a story about the PEAK also. Like PEAK came up with a lot of innovations and a lot of performance and a lot of reliability aspects to it, like giving a on-chip oscillator, power on oscillator, power on reset, and watchdog timer, brownout reset, so many features to it, which again ensured the reliability of the development. And at the same time, PEAK also brought in many things like RISC, Harvard, pipelining, so therefore a lot of performance to the chip. And at the same time, PEAK gave a kind of thing like every instruction can be performed within 1 or 2 machine cycles. and would consume just 1 or 2 bytes of the code. So this is how every chip has got some story to it, and therefore selection of the each controller will mean something to you while you develop any kind of industrial applications. Now coming to the next consideration, we have by now we have been already aware what is embedded system. It takes the data from various means like human machine interfaces or sensors, etc., processes it with the various inbuilt algorithms and actuates the final action in terms of actuator. So we have seen that the controller is the brain of the embedded system, which reads, writes, and control and stores the algorithm. Now here are the factors which are shaping the selection of the microcontroller, because while you develop any industrial application, you cannot just go pick any controller and start developing it. Even if you take the example of PIC, there are so much of variety. 12-bit family, 14-bit family, 16-bit family, 18-bit that family. So low scale, medium scale, and high scale, sophisticated scale. So there is a lot of variety to it as far as the 8-bit controllers are concerned. So what are the factors shaping performance of microcontroller? So what do you think? If I talk, because controller, selection of the controller for any industrial application is an important aspect. Okay, besides talking about any other peripherals or so, but the processing, okay, the processor. So what do you think, what are the factors which shapes up the performance of the microcontroller? Any center, would you like to interact on that? Can you just name few things, the factors which are shaping the performance of microcontroller? Because the performance of your core, the controller, will give you the performance in the development of any industrial applications. Like you select your mobile, so you go for this, you always make the selection. So what are the factors you think are important while we select the microcontroller? Which center is there? Yeah, any center, just name. PVP Siddhartha. Can you just name, this is very simple thing basically. So what are the factors shaping performance of microcontroller? I can see the madam is smiling. So PVP Siddhartha. So what are the factors you feel that are important while shaping up the performance of microcontroller?
Good morning, sir. On-set memory, on-chip memory.
Good. Yes.
Instruction set.
Yes, great. Wonderful.
Service of the provider.
Service of the provider. That will come later on. Like we have many other aspects like power consumption, cost, tool availability. But as far as the factor shaping performance, you said very rightly, these are the important considerations. But most importantly, when we talk of this, what happens, like you can see here the answer that which includes the instruction set, size of the CPU, which is very common and oftenly talked about, like whether it is 8-bit or whether it is 16-bit or 32-bit. The size of the CPU matters a lot. And obviously, like instruction set, and as you know, in case of PIC, we have RISC in the instruction set, and so whether it is RISC or CISC or combination of both, and whether it is having 32, 75 instructions, that all will come into picture, because in PIC 18 also there is a series from 35 to 72. So while you make a selection, instruction set will definitely matter. Then size of the CPU matters. Then despite all that, and in PIC we have separate buses also, that is hardware architecture and pipelining, etc. But then real performance will vary application to application. What does that mean? Basically, if you make a selection for something, let's say very small application, any remote or very small compact thing which belongs to small scale embedded system family, and if you now make a selection of a controller, and now what you are doing is you are putting the same controller to some other application which belongs to medium scale family, so definitely the real performance will vary application to application. It's not that you do it theoretically and then you find you expect that same should be the performance. So the application to application, the real performance will vary, because some application includes more complexity and some includes less complexity. And beyond this, basically, if you don't think that you will not be able to give good considerations to rest of the factors, then A very rough layman's estimation is actually you will check on what is the MIPS, million instructions per second, is a very rough estimate as far as the performance of any controller is concerned. So any manufacturers, whether Atmel, PIC or Silicon Labs, any manufacturer of the controller will essentially include this parameter when you go for the selection of the controller. And that parameter is nothing but the MIPS, million instructions per second. It is a rough estimate. Don't consider it as a final estimate. It is number of instructions that it can perform per second. Okay, so million instructions per second, MIPS, they call it MIPS in short. There is also some keystone, also kind of another factor which means. So this is one terminology in the case of glossary in the embedded system, which talks about the performance of the controllers MIPS. So number of instructions performed per second. So MIPS. And you can say in PIC we have 50 MIPS, 16 MIPS, up to 100 MIPS, and Silicon Labs C8051 F120 will give you 100 MIPS performance. So these are some indicators of the performance of the controller. Similarly, amongst all these important considerations, the last which says that routines are designed to test the processor. The best thing is to see that there are routines, and if you put some routine on a particular chip, there, let's say manufacturer 1, manufacturer 2, manufacturer 3, or within the manufacturer there are set of families. If you put that instruction set or set of routine to that particular processor and check the performance, how is that performing in terms of speed, etc., then that is the best way of checking the performance of the processor. So moving further, besides once you ensure that okay, the quality of the performance of the controller is fine, now there are some other considerations which includes the power consumption. Okay, so while you select the controller, besides core and its instruction set and MIPS, etc., then you will also consider that what is the power consumption of your controller, because embed system, when we talk of embed system, means the important constraints and the characteristics of the embed systems are cost effectiveness, space effectiveness, and power effectiveness. So how much is the power that it consumes? So that will be the important consideration, microamperes or so. And then of course the cost, as you know that every penny counts, even 1 rupee difference from one controller to other controller. For example, that silicon chip costs 100 rupees or 200 rupees when purchased in a bulk, and Atmel will cost 50 rupees or Intel will cost 50 rupees. So you have to make a wise decision in terms of the kind of controller you are putting in your application, because every penny counts. And as you know, if there are 1,000 users or billion users, and these days, make in India and make for the world, you are exporting also, and you are satisfying your domestic needs also. So definitely it is a volume game. And especially now the China is competing with everyone, so whatever you will develop, it has to be strong competition with the China. And definitely India, talking on the other note, India always has innovation in terms of developing something which is cost effective or performance effective. The good example is that Tata launched the Nano, and which was the world's most cheapest car. I don't know about the success story. They lost some ground because of the thing that happened in Bengal, West Bengal, etc. But they could, it was the engineering. Talking about the engineering performance of it, then definitely they launched something which was very cost effective, and that Tata Nano almost filed hundreds or plus patents. So therefore, cost and performance effectiveness was there. So therefore, my point is that when you develop any product, the cost effectiveness should be there and performance effectiveness should be there. And cost can be brought down with multiple aspects, like few things which you can develop using the software will be more cost effective, because for the similar thing you can have hardware and you can have software solution also. They can be co-development also. So cost will matter when you select the controller. Then another factor is the tools availability. What is this tools availability? You know that when you develop the embedded system applications, you will need assembler, debugger, compiler, etc., all these emulators and development tools. Do we have the tools availability reasonably? And for that matter, I would like to show you one video, probably that is 10 or 12 minutes video from the PIC, and which shows that how the different families are available very cost effectively, and therefore it will serve your purpose. Then reputation of the company, that the company should be well reputed, that it should be in the market from long time, and it's not that today you are buying something, developing some product, and tomorrow you will find that company is no more there. So many times it happens, and like Motorola was taken over by Freescale for some this silicon business. Then Silicon Laboratories was earlier called as Scilabs, and there are many things we know that the people, then they take over. Recently, like in Agilent, also many takeovers took place, and then earlier company got acquired, and then as a result some market suffers. So the people like developers also suffer. So therefore the reputation of the company as far as the long-term planning is concerned definitely matters. And then application, obviously application will be the most important factor. Then now let us come to the efficient design considerations. So as I was saying that before we see actual applications, then let us talk about the efficient design considerations. The efficient design considerations include the hardware and software. The first point you can see is the fewest voltages. What is this fewest voltages, and how is that relate to the efficient design considerations? You might wonder on most of the aspects here, but these are the important things which one might consider when we design the efficient embedded system development considerations. So few voltages, what does that mean? Let's say you are developing some product or application, industrial application, then in that if your chips are using, let's say they are working on 3.3 volt, okay, and then you are connecting the LCD, okay, LCD, and you're using that LCD of 5 voltage, okay, which needs the DC 5 volt. And what you will see that your board will need now more than 1 voltages. It will require 3.3 and 5 volts. So what is the big deal, you would ask? What happens that you will have to manage everything. You have to now manage the power management, in that you may have to select some power management IC, or you may have to connect 2 regulators, 3.3 volt, 5 volt. The overall cost of the PCB, the component, the reliability goes down as soon as your components increases. So therefore you have to be very wise in terms of the selection of the voltages that you are using in your application, because these days if you use the single voltage based application, your cost will definitely come down, because the LCDs are also available for 3.3 volt voltages and that range. So therefore you have to be wise while you make selection of the components and the voltages that you will be using. So obviously a person who is using one developing application with the 5 volt and other ICs working on 3.3 volt, and another one using 3.3 volt complete boards, his cost will definitely go down, his reliability go up. So definitely that is a better product designing. Then next point comes is the conserve power by smart choices. What does that mean? Most of the applications are battery driven. So when we talk about the talk of the battery driven applications, you have to think of the options of saving the power. So conserve the power so that your battery is lasting for more and more time. So conserve the power is the most important thing, and therefore you should make the smart choices for conserving the power. And you will see in most of the things like shutdown when not needed. So what happens when, like your mobile, when you are not using it, automatically goes to the shutdown mode, or its backlight goes off. So that means it is conserving the power, or it is shutting down, and somehow it is actually reducing the use of the power, and therefore it will have a long lasting battery. So these are the important considerations. So most of these are common sense also, and few are very technical, like I'll explain few of them. Then availability, you have to also check the availability. If the component that you're using are not easily available, definitely it has impact on the development cycle and the cost effectiveness. Then temperature stability and calibration. It happens that temperature has an effect and impact on everything almost, whatever you do. So there is a temperature drifts. So therefore temperature drifts, because of the temperature, whatever drifts happen, whatever errors happens, you should be having inbuilt calibration algorithms to take care of them. So these are the factors. Then what is it developed to the eventual form? Can you have any guesses? Developed to the eventual form, what do you understand by that? Developed to the eventual form means that what you are developing should be, let's say you are developing a product which is as compact as your mobile phone, your cell phone, isn't it? So, and if you start developing something, if you are asked, okay, as a design engineer or embedded engineer, okay, you develop this product. Now your product requirement is that as compact and as small as your mobile, and you start developing, okay, I'll start developing with the desktop PC. Okay, with the desktop PC you have started development and you are developing that embedded application, and then okay, it starts and it works, it functions the way you want it, whatever is the desired functionality, it is able to do that. But then you will find that that is not your eventual form, and then what will happen, you will start reducing it to the eventual form, that is the compact as mobile, and you will lose the time on that, and you are losing the many resources, you are losing on the expenditures, a lot of investments are happening. So therefore it is advised that whatever you want to do, you have to start developing into directly that form, eventual form. Then fuse boards, what do you understand by fuse boards? You should be using as less boards as possible. What do you understand by fuse boards? Anybody, any center voluntarily would like to talk on that? Fuse boards, one of the hardware consideration for the efficient designing is fuse boards. Fuse board means as less as possible. The number of boards that your embedded system application includes should be as less as possible. Fuse boards. What is the important thing about the fuse boards, you think, in your opinion? Yes, any center? Any?
Ask from Indira Gandhi.
Indira Gandhi Center. Yeah, can you hear me? Indira Gandhi Center. Anybody voluntarily would like to say on this aspect of fuse boards as an important design consideration? What do you understand by that? Okay. Now Northern India. Any center with Northern India? Would you like to say something on this aspect, fuse boards? What do you think that design consideration, efficient design consideration means when we say that it is a fuse boards? It should be the fuse boards. Well, very simple. I'll answer on that. So what this fuse board means basically, okay, very simple. From the name itself, it is very clear that you should have as less boards as possible when you design any embedded system. The biggest impact it has on your reliability, because if you increase the number of boards, the chances of failures, number of components increases, the chances of failures are more. And obviously when you have more number of boards, the common sense there says that it is having a more cost, because every PCB, because PCB manufacturers, most of you from electronics background might be aware that PCB manufacturer count the price in terms of the square inch or that square mm, how much is the board size. So therefore that matters. And then here it has also impact on your compactness. So your cost effectiveness will go down, your compactness will go down, your power efficiency will also come down, because you have more boards, so it will have more losses, and reliability most importantly. So these are the repercussions of not having the fuse boards if you select more number of boards. Then now coming to the software aspects. For efficient design consideration, your code should be easy to understand. The simple reason for that is, like, you might be working in a team, and if you are developing your code, if it's not simple to understand, maybe sometimes your other team member is referring to it, or you might be getting transferred, or somebody else is replacing you. Then in those all cases, your code should be easy to understand. There should be enough commenting and all that. And so documentation and the reliability is something it has to do with this easy to understand code. So because these days the products are always updated. You see that market is so fast changing and ever changing that it keeps changing every time, because you see today we have one mobile model, or tomorrow we have another mobile model. Same is the case with any other sophisticated gadgets that we are using our day-to-day life. So we have new model. Yesterday I was having smart TV, today I am having Android TV, more smarter. So everything is changing, ever changing, and they are changing with a rapid pace. So with this rapid technology advancements and changes, you have to, as a developer engineer, embedded engineer, that your design consideration includes the important aspect that what you write as a software should be easy to understand, so that there is a changes that can happen very easily by your teammate or other part of the team. Then functions. While you develop the software, another important common sense consideration is the functions. I mean, you should develop the things in functions and functions, like you are writing about the LCD. If time permits, I'll show you one of the example of LCD, how to do that, or LED. Then you have to write it in terms of functions and functions. That means you are writing for LCD data, LCD code, and for delay. So you should develop the small functions the way we do it in the C language. So for every functionality, you should have, like for example, you are reading some, sensing the data at the input. So let there be some function for sensing the sensor, particular sensor. If you are controlling, let's say, motor application, you are sensing the pulses, then you should be having some another code routine for actuating. Okay, so that is how you can have different functions for different functionalities. Function means for handling a particular function, so you can have different functions for handling the different functionalities. Then necessary precision, which is very important aspect, and very often the design engineers, they commit a mistake on this. In fact, that is what normally is happening. I mean, that was happening in India, जहाँ पर आपको 2 लेन बनाना था, एक ओवर ब्रिज बनाना था 2 lanes का, वहाँ पर हम 4 lane का बना देते हैं, where there is no that much traffic is not required or is not available. We'll make 4 lane वाला bridge, and wherever it is actually required 4 lane or 8 lane, वहाँ पर हम 2 lane बना देते हैं. So we do kind of over design or under design. So necessary precision has something to do with that. Like you have to design your embedded system. If you need 8 pins, you should be using 8 pins controller and not 18 pin controllers. So necessary precision, because again it has got an impact on the cost. So cost is the most important driving factor these days, and is an important factor for the sustainability. So necessary precision should be taken care that how much is required, whatever is required, that much should be designed. So necessary precision, there should be a balance, enough balance, good trade-off between what you are doing and what you should not do. Then tables or calculations. Okay, if you are writing the codes or something like that, and it includes a lot of calculations, so you are keeping your CPU busy, and your CPU, the best example is like even on laptop, if you keep on opening number of windows, what you will see that your speed goes down, your speed reduces, because parallel processing is happening. So in case of embedded system also, what you should be doing is that you should not be keeping your CPU busy. So let's say you have some application wherein a lot of calculations are required. One of my recently a PhD scholar is developing some algorithms for extracting the sine wave correlation fitting components out of that impedance vector. So I asked him, instead of keeping the CPU busy, what you do is you do everything offline. Okay, you develop this algorithm and on the desktop PC first, find out the components, find out the best algorithm, best fit function, and then finally program those regression coefficients and along with those design variables inside the core controller. So this is how we can do. And another thing is that you can use the tables. You can just look up tables, you can pick the values, and you don't have to keep your CPU busy. So that is what it says. And real-time interrupt. So there is a vector polling, and there is there are 2 methods. So there is for when you develop any kind of real-time systems. So there is a vector polling, and there is scanning technique. So in scanning technique, your CPU continuously keep on scanning the the event. Okay, whereas the interrupt driven, the vector driven, that method is very efficient, because that they are inbuilt, and those interrupts are having a particular vector location or addressing. So that is the real-time interrupt consideration. Then multitasking. So this is also an important factor. Okay, so with that we are done with the important design consideration that we should be making as far as the designing embedded system is concerned. Now let us talk about now what happens is that any industrial application when you develop, like we will see one of the examples in the areas of food sustainability, you will come normally across the kind of peripherals that I have listed over here on my slide, which include LCD, keyboard, motor, graphical user interface, GPS, okay, for sensing your geographical coordinates, RTC, gyroscope, and different sensors are available these days, heaters, coolers, relays, GSM, okay, Internet of the Things technology or wireless sensor network, Bluetooth, Zigbee, and any other sensors, okay, color sensors, LEDs, and list goes on basically. So whatever is your real-time requirement, this kind of peripheral you'll come across. So you'll come across the analog and digital peripherals that you might require to interface with the embed system. Now, so these are the, I think these were the important applications. And these real world technologies we'll be talking today about is the food quality parameters variations. And now I'll come to that real world applications. So I'll switch over to another slide here. Yeah, so yeah, so we started with this, and today what we are going to see is about the real world application, industrial applications in the areas of farming, or you can say food sustainability. So food sustainability, and as I talked, there are variety of challenges that we have been facing. This system, this agriculture production system is facing. So one of the thing for increasing the food quality and quantity is we produce more with the better practices. And second thing is we preserve more. That means whatever is produced should be protected more. Okay, then only we can have enough food available, good amount of food available, and we will be also maintain the quality of it. So how do we do that? Okay, how do we do that? How do we produce the more food? Okay, food production, increase in the food production. Okay, so that area belongs to the pre-harvesting. In pre-harvesting area, for whatever practices or techniques or technologies that we follow for increasing the production of the food comes to that area, that is called as pre-harvesting. And once you produce something, okay, whatever is produced, then what happens? We store it in the godowns, or we store it somewhere, and we procure the things, we store it, we process it. So that area is called as post-harvesting technologies. Okay, post-harvesting. That means after you harvested the production, then you are dealing with it. That is the post-harvesting technology. So whatever is produced, if it is produced in a quality and quantity manner, and whatever is produced, if it is saved, protected, so we are not doing the losses, so that will ensure the sustainability. And just for your information, you'll come across also variety of things. My contribution in this actually building the technologies for sustainable future food inroads by creating presence in food consumption and production domains. So the technology that you are seeing on the left side is a tractor mounted soil mapper, which actually maps the soil characteristics, like you know well, for production of the for good agricultural production, the important aspects to plant is actually the soil in which it is planted, and temporal factors like weather factors and the growth of the plant. So there are two factors, spatial factors and temporal factors. The spatial is actually the primary media, that is the soil. So if it is a good soil and good manuring is done, nutrients, etc., irrigation, fertilizations, then it will have good growth. You might have seen that one field is having good growth, but other field is not having good growth. Punjab region, they are considered the football of the country. So the farms are good, you know, and Punjab farmers are more prosperous than any other part of the country. So there is a variety, there is a difference between fields also, the quality of the soil. So therefore the primary media of the good production is like the soil, and the second is that your temporal factors, how is the crop growth, and how is the health, and how is the weather, and all those agronomic conditions. So there are these. So in terms of agricultural domain, they say that spatial and temporal. Okay, although I'm actually electrical and electronics engineer, but now working with this, I got some acquainted with these kind of terminologies which normally agriculture people use or soil people use. So these are the two factors, spatial factors and temporal factors, which govern the productivity of the farm. So just let's say, imagine if you give the good manuring to your fields, like good nutrients, good irrigation, and good pesticide, etc., a controlled thing kind of thing. So your quality and quantity of the food is going to be very good, isn't it? You see, for making a difference, to differentiate, I can just quote one example. Like if you see American apple, okay, and compare with the Indian apple, have you noticed the difference? I think American apple costs something around 200, 300 rupees per kg, and Indian apple will cost 50 rupees or 100 rupees a kg, something like that, in that range. And but the difference is noticeable. What you will see that American apple is very good shine and very good taste and all that. Okay, mostly you'll find in Walmarts or this kind of things, or maybe there are some other sources from where you can get it. But normally you will see that imported things, products, are of good quality, and of course they cost more also. So why it is so? My point is why it is so, because if something is done in a controlled manner or optimized manner, like the kind of nutrients or manuring that it is receiving, if it is a good quality, okay, everything is well maintained, the atmosphere is well maintained, then what happens is that you will get a good quality produce. Okay, the quality of that thing is good. So this kind of technology that I am mentioning here, the soil mapper, is a kind of a scanner which actually scans the soil surfaces. Just it is mounted on the tractor, and the way we scan, our scanner works, it scans the soil surfaces, and by scanning it, as you can see, then it gives the expert decision support system to the farmers or the people concerning that, and tells that how much is best, how much is amount, what amount should be applied, nutrients or irrigation and pesticide, etc., how much should be applied, where should it be applied, and when it should be applied, what type should be applied. Like different crops have different requirements. They have different requirements in terms of the quality as well as the quantity and what type. किसी को NPK चाहिए, किसी को और कुछ चाहिए, माइक्रो न्यूट्रिएंट्स, इरिगेशन कितना चाहिए. So this technology basically optimizes the input application to the farm production system in terms of pesticides or any other things that is governing it. So optimizing this input application to the farm production system is resulting into many things. As I said, sustainability. It is resulting into, when you optimize the input application to the agriculture production system, the farm systems, you are actually securing many things. When you are optimizing and applying only exact amounts, then what happens is that you are producing the quality, good quality and quantity, because everything is received in a right manner. Then even then everything is right. Okay, right proportion, so right thing happens. Like, if let's say, if I give an analogy, like children are also like a plant. If they are given a good manuring and incubation, right things, right culture, right practices, right all these things, then the personality grows very nice, very fine. The same is the case. The plants also, if they receive everything in a right manner, then their production quality and quantity is very good. So therefore, by optimizing these things, there are multiple things that we are able to achieve, that we are able to get the right quality, that is good quality. Okay, it is not that what you are consuming is full of fertilizers or pesticides. So very good quality, like we find in developed countries like kind of America or any other country, the good quality of the food. And then quantity will be also good. Okay, and then since you are applying in an optimized manner, you are not wasting it, so your ecology is also not getting damaged. Your natural resources, like your water resources, are not getting contaminated. Your soil is not getting contaminated. Your air is not getting polluted. So environment is remaining intact, and that is what the sustainability is all about. Because you don't want to feed your population for today. You also want to think about the tomorrow. What about your future, your children? What will they eat? Because see, population is, and everything is continuously growing. Your demands and your needs are continuously growing, but your resources, your natural resources, the important critical resources, they remain fixed. They are not changing. They will not increase. But you are depleting them. You are contaminating them. You are depleting them. You are deteriorating them. So therefore, the kind of technologies I am talking about, the precision farming technologies, they are ensuring that you are getting the nutritious food for the people, but you are not damaging the ecology. And at the same time, when you see market mein aap jate ho, if you are buying a ghee, I am aware of the ghee, the desi cow ghee, which costs rupees 1200 rupees a kg, and then another side you are having a ghee available at 400 rupees a kg. Okay, and same is the case, like I talked about the apple, 200 rupees or 300 rupees kg, and another is of 100 rupees kg, or like that. So for everything there is a variety and quality. So when quality is good, your rates are good. Okay. So therefore, if you are doing all this nicely, your quality quantity is increased, your ecology is safe, and profits are increased. Your profitability is increased. Okay, and profitability is increasing because of two reasons. The farmers who is producing is the profitability is increasing because of two reasons. One is he is getting a better quality, so he is fetching better rates, more rates, and second thing is that he's having more quantity, so again it is fetching him more profits. And third thing is that while doing so he's applying the optimized inputs. That means wherever it is required only 1 kg of the nutrients to be applied, NPK or something like that, or pesticides, he's not applying 10 kg or 1 ton or etc. So that means you are not wasting, there is no wastage. Whatever is required, how much is required, and wherever it is required, because these technologies are GPS, are also fitted inside the embed systems. So those GPS gives you the location where to be applied and how much to be applied. So therefore, when you apply rightly, so you are saving upon cost, input cost also. Your efficiency, input efficiency is more. Your farming efficiency is more. You are applying less and you are producing more. And you know what is happening? The farmers are doing suicides because they are having a lot of debts. कर्जा है उनके ऊपर, because what they consume, they are applying more and they are producing less. Why? Because they are applying only more, because pesticides are not required more or fertilizers are not required more, but they know if they are applying more, then they are producing more food, but that food is of no use. I'll show you in my few slides what is happening with that, or excess application. So these were the side effects of the green revolution. So I'll talk about it in details. And second technology is, जब आप एक बार produce कर लेते हो, so you have to protect it. So another technology is if you moisture measurement technology. When you store these agriculture produce in the godowns or storage houses, you have to maintain their moisture. If you maintain their moisture, their shelf life is increased, and the losses are not happening. You'll be surprised to know that the losses in our country are around 50 to 1 lakh crore rupees. 50,000 to 1 lakh crores are the losses of our country each year, and the amount is so huge is that this much amount is normally produced, half of the amount is produced by the country like Australia. The amount that is complete amount produced by half of the amount produced by the country like Australia, that much we are wasting every year. You can imagine the gravity of the situation, and we can easily feed over 1/3 of the population of our country, which is below poverty line, with that much amount. And then we talk about the availability of the food, etc. But that much we are wasting just because we don't have the right post-harvesting technologies. So you can imagine how important this area is. So these two areas are very important. If they are not focused and worked upon, then we are not going to get the food. Because in coming days, see, developed countries have already reached their plateau. You'll see in my slides now. So, friends, we have been talking about the food sustainability, but while we are talking about this, there are so many challenges, environmental issues like climate change, conservation, energy, environmental degradation, soil degradation. A lot of things are happening. Water is degrading, contaminated, but these are the challenges for our sustainability. But we have to produce, and building sustainable system is a challenge, because good things, they take time. So how do we do that? Now I'll show you some figures. Our GDP distribution is something like this. 60% agrarian country. India is called as the agrarian country. 60 to 70% resources are consumed by agriculture. Industry 10%, services 30%. But when we talk of GDP, the contribution of agriculture is very less, and mostly it is coming from the services. Industry, manufacturing is slowly increasing and doing good job. But unless India does better on the agriculture front, we cannot be a developed country. Another factor, population of India is increasing. As I was talking, that by 2050, 9 billion population is going to happen. So I'm just showing you some figures. What are the challenges of food sustainability? India is almost surpassing China, or surpass, you can say, in the population. But the basic needs are still remain same. Whether it is a developed country, kind of USA or India, it remains same, that is food and cloth. So how do we meet these basic needs? That is the challenge. And the background, although that is the challenge, I'll just tell you something about the background. When post independence, what happened? We were under starvation. Okay, India was like considered a country wherein a lot of starvation happens. People were not receiving having a food, and there was a mismatch of demand and supply. The required amount of food was not equal to the amount of food being produced, and we were mostly dependent on the imports. Then Green Revolution happened. After Green Revolution, what happened? The food grain production dramatically increased from 74 million metric tons in 1967 to 212 million metric tons. That is almost triple or four times rise. So with that, what happened is self-reliance happened, but we were not still self-sufficient because still we were not producing everything by our own. We had some self-reliance, but not sufficiency. We were still deficient on few aspects. But the worst thing that happened in case of Green Revolution was use and misuse of the fertilizers and pesticides. And that is why these days you find that a lot of hue and cry about organic farming. So I'll not get into that subject, what are the merits and demerits of all that and what is happening. But organic farming is definitely, good. So then onset of knowledge happened since then, since Green Revolution. And there are other figures like India is a global rank in few things. Like in rice, wheat, sugarcane, pulses, we are almost second or first or third. And we have great global production share, and Punjab has been football and having a lion's share in all this. Dr. Norman Borlaug said that food is a moral right. Once you take a birth, it is a moral right. Like in our country, they said that right to education. They also came up with right to food. So it has become right. Once you take a birth, it becomes a right to have a food. So right to save food will also come in picture, I think, shortly, or right to secure food or food security bill. So these are the things these are the recent developments. And what Green Revolution is, it used a lot of high yield varieties, use of fertilizers like urea and use of pesticides. It all started in 1960s. And it resulted into huge increase in the crop production. Like our rice crop production increased multiple tons from 2 to 6.5 tons. This happened. But you see, I was talking about that, okay, you got the food, self-sufficient, self-reliance, but it was like, I'm giving you an analogy, like a person says that, okay, I want to do a bodybuilding, okay, and you can do the bodybuilding, and you are doing the bodybuilding and then you are taking the steroids. Okay, you can see that, okay, there are good muscles. In the picture you can see that use steroids for bodybuilding. This is something like, this Green Revolution and increased pesticides and fertilizer. It is analogy to that. You are able to produce good food, but it is poison. So in bodybuilding, you are producing the body. You can see good muscles here, okay, with the steroids. But what happens? There are side effects. You can see that intestine and then lung cancer and all these ill effects when you take the steroids for bodybuilding. So basically, in Green Revolution, although you could produce lot of amount of the food, but it is like poisonous, becoming a poisonous. Trace metals, it is coming into the food cycle of the people, food chain system. It has getting into the food system, food chain. It is coming into our body, human bodies. So therefore, there is no rose without a thorn. So there are a lot of negative effects that have happened in the Green Revolution: degradation of land, degradation of trees, and loss of biodiversity, water pollution, and water table depth, etc., etc. So it's very, challenging now. So the bigger question is, how do we meet the food demand by 2050, which is going to be 9 billion, the population of 9 billion? How do we do that? And it is most important for the countries like India to think on that, because this increased food demand will be made by the developing countries like India. Why so? Because the developed countries, for that matter, they have already used all the latest technologies for doing that. So when we talk of industrial application of the embedded system, we have to use this latest technology, and I'll show you in few examples now here that how this technology can be a game changer. So for a developing country like India, from where only this increased production requirement will come from, because developed countries have already reached their plateau, they have saturated by producing, they are already using the latest technologies, but the developing countries like India are not using it. They are still producing, underproducing basically. They are still underproducing because they are not following the right technologies. So you will see that how it can happen. How can we solve this question, bigger challenge? We have already seen there is a challenge, and we have to do it sustainably. Like people should get nutritious food, environment should not be damaging, it should be profitable. Another problem, if you see the global scenario, is that globally there is a degradation, undernourished, uneaten people, agriculture, population, hungry, employment. These are all the aspects related to this sector. Now, according to the World Resource Institute, it says that there is going to be 70%, there is a gap of 70% between the food available today and that will be required by 2020. The food that you will require by 2020, there is a 70% gap that we are producing today. So how will we meet that demand, because your resources are depleting? So therefore it is a very, very challenging question, and a lot of research is required in this. The national scenario is also not very rosy. It is also very gloomy picture. Our highest yield producing variety is even not able to produce what the developed countries are producing, their average yield producing variety is producing. Their average yield is higher than our highest yield producing varieties. So you can imagine the situation. Suicides are happening a lot of, and recently because of this all urbanization, smart city, etc. are coming up in a big way, and you can imagine what is going to happen in future. The land that is under cultivation is going down, and population is increasing. So I think you are very wise people. You can imagine that from where to meet, what will happen. That means from the same land you have to produce now multiple times without damaging, still nutritious. So the only solution is the technology. You can again see that in Asia we are in the hunger spot. The country which is under a hunger spot, the major area is India, which is a hunger spot. That is people who remain hungry more. So we are under that. Almost three children go hungry to the school. So this is very actually severe picture which we are not aware of because we are getting enough food. So the whole thing is that there is a food crisis. There is a food crisis. So how to, therefore I talked about two technologies, pre-harvesting and post-harvesting. They matter a lot. These are most relevant. India's agriculture production growth is going to negative. You can see in these figures here, these grains, pulses, all these are going into negative. I am showing my arrow here, they are going negative. So how do we attain the food sustainability? That is a challenging question. And technology is the solution, like embedded system, how that can be used, how we can use the robotic systems, how you can use the unmanned aerial vehicles for developing good harvesting practices or precision farming practices. So as per this post 2050 development agenda, we can produce more food or we can protect more food, and that is how we can get the food sustainability. So one area is pre-harvest, another area is post-harvest. So sustainably we can increase the crop yields production. How can we do that? You can see by using a lot of devices, all embedded system gadgets, wireless sensor network technologies, unmanned aerial vehicle, drones and robotic systems. So all these if we start using, and information technology, you can see different data layers, Internet of the Things, cloud, big data, all these technologies, if we converge together, then we will have emergence of a new era wherein we can have a sustainable technology. So you can see that all the gadgets, all the technologies can be put together to get benefited for this factor. So we will need science and technology for guiding the farmer, for enhancing its productivity, and there are a lot of things to be dealt with, input output situations, which is a control system. In farming system there is input and output, and there is a lot of modeling etc is required. And so what is the solution is that we can, there is some term kind of called as precision farming. What happens is this, that you can see there is a map here. That map will guide the farmers what to do, where to do, and how to do, how much to do. So all these optimizations techniques, decision support system wherein you can put in a lot of artificial intelligence, okay, a lot of big data mining technologies, a lot of signal processing technologies, okay, a lot of embedded system technologies, all put together can serve the purpose. So what is precision farming? In precision farming, what happens is that we take care of every fertility attributes. It is recorded on a precision scale, that what is existing spatially, what is existing temporally, the whole modeling takes place, and we can develop a decision support system which will help, which will produce the best agronomic decision making practices. Okay, and as a result farmers will be able to make the best decisions, because earlier it was like, uh, in farming family it was like a family business. बेटे father के बाद बेटा कर रहा है, so that knowledge was getting transferred. Okay, that was the situation. Small land holdings, that knowledge was getting passed on to the sons. Okay, so they were undertaking the farming, but and that used to be a joint family. But no more is the situation now. Sons are not no more working in the farms. They are moving to the urbanization or to the cities. Okay, and very few are staying with the farming community. Okay, another challenge is that earlier it was not like that. The weather conditions and environment was not that complex. Now there is sudden outbreaks, lot of outbreaks, disease outbreaks which are coming to the fields and crops which are not even known, and so farmers use a lot of pesticides etc. So the dynamics of total farming system changed to the extent, and it has become complex to the extent that a normal human being like farmers cannot handle these situations by their own. So they will need, robotic systems or decision support systems, these all complex systems. Farming, mobile farming, you can have mobile farming in, you can have different wireless sensor networks planted in your fields, and they are taking care of the irrigation, they are taking care of the nutrients, they are taking care of all the requirements. So unattended and still precise and all that. That is what this precision farming is all about. So you will have differential action. For example, at present what happens is that farmers, they are applying the dosages or inputs just rampant, without any rational, without any logic. In the whole field they are applying the same amount. If it is 1 acre, 10 acre or 100 acre, if they are applying something, they are applying in the same amount. There is no variability in that. Meaning that you see in one area, and on the other hand in your fields your production is not the same. In your one part of the area of the field you are producing 1 ton, and in another part of your field you are producing 5 tons or something like that, but your input applications are same. So one plant requires 1 kg of fertilizer and other plant may require 10 kg of fertilizers, but presently the practices that are being followed by the farmers is that they are applying 10 kg to the whole field. That means one plant is getting overdosed, and there might be third location wherein that needs 20 kg, so that is getting underdosed. So one area is getting underdosed, another area is getting overdosed. Okay, overdosed and underdosed. So the thing is that the plants are not receiving the right inputs, so they are not producing the good quality and quantity of the yield or production. Another scenario is that in particular field some particular crop grows fine, but you are putting something else without knowing the condition, pH conditions or any other conditions of that field. You are just putting any crop. So that is another scenario. In third scenario, space between, distance between the plants. Okay, spacing between the plants. If that 1 centimeter by 1 centimeter area or 1 feet by 1 feet area, you have to plant only 5 plants, five samplings, but you are planting 100 samplings. Just for the example, I'm not going, don't go with the precision, but 100 samplings. That means, which is not the production potential, which is not the fertility potential of that field. So everything is just mismanaged or messed up, and as a result, farmers are doing suicide, because most of the problem in India are messed up, mismanaged and indisciplined. Whether you take the traffic, or you take the farming, or anything else, everywhere it is indisciplined or messed up. The lack of management. What I see on the roads also, on the separate note, not I am talking about, on the roads, that it is not always that the roads are small, or you can say, okay, part of the problem is because of the roads are small, and part of the problem is because of the indiscipline by the people. They will never go with the lane. They will never travel with the discipline. So as a result, lot of accidents, or jahan se traffic can be easy, there you will find lot of traffic problems. And the good thing is, like, I can quote you example. You see the example when the traffic lights stop working. See the mess, how the mess gets created. As long as the traffic lights are working, the traffic is fine. As soon as the traffic light stops working, a lot of mess is created. So the management problem. My point is management problem. Like we see in the traffic, same way is the case of agriculture. There is a mismanagement. So the technologies that we are talking about, precision farming technologies, is about building a good practices, good management practices. So good agronomic management practices. So these technologies, like the tractor mounted technology, wherein you can have spatial variability sensors, temporal variability sensors. So they will give you all the picture about pH, moisture, temperature, nutrients, clay, everything, etc., etc. All fertility attributes, organic matter content, CEC, and all these fertility attributes are mapped, and then now how much is there already, and then how much you need to apply. So there will be decision support system, maybe on your mobile. You can just, and then in your fields there are already actuators which will get actuated and apply that much input to your fields. So controlled farming. Okay. So this kind of controlled farmings. For example, one more analogy I would like to give. What happens when we okay, let me complete this first. So once you have this all spatial temporal mapping through these all technologies, wherein GPS is attached and all this connected to the tractor, the scanner, this goes, I'm showing my mouse, pointing my mouse. So spatial variability, temporal variability, all this going to the decision support system, all your artificial intelligence, different algorithms comes into picture, machine learning, etc., data mining, and then this goes to the variable rate technology controller. For example, you might have seen the farmers in their piggy bag, they apply the pesticides, okay, with that sprayer. So imagine in the situation in their piggy banks now, that data layer controller is there, and in that data layer, whatever is mapped already by the tractor, that data layer goes as a soft input. Data layer is input as a soft data layer input, and automatically that farmer is not now doing anything. That sprayer will automatically actuate that much input of application, because it will be all automated. So the piggy bank will have that data layer inside it, and the controller will automatically do on and off and switching of that sprayer to the amount required. It will spray that much amount only. Whatever is required in that particular canopy or area of the field will automatically go on applying. So there will be no wastage. So similar will be the case for the nutrient application or irrigation application. There will be a controlled, whatever is required, how much is required will be only applied. So you can see that through these variable rate controllers, optimal seeding patterns, plantation, crop protection, nutrient application, irrigation is happening. So this all technology is all about. The another analogy to this technology is like human being. We go to the doctor. When we go to the doctor, what happens? Doctors diagnose ourselves through different tests, blood test, pathological test, CT scan, MRI scan, etc. So these different tests are nothing but the data layers, different data layers of our body. So when doctor sees different data layers, then they diagnose properly. So more is the data, better is the prescriptions he writes, and better are the chances that you get recovered. So better will be your health. So whatever, so what we do is, whenever the problem is more severe, we go to the specialists. So what they do is they conduct more tests. So there is more data. So this precision farming is all about that. So in case of doctors, if there is a problem in your hand, so the medicine gets applied to only that particular location, let's say in your finger. So only targeted delivery of the drugs. So only that much area gets treated, and it performs the job nicely, effectively. You don't apply the medicine to your whole body if it is required to only to the finger. So that is targeted delivery, very precision delivery. The same is the case with the soil. I can call this as a soil doctor. So this technology tells clearly where to apply, how much to apply. So applying every inputs very optimally. So this is what this technology does. And while doing so, you can see all these controllers are used inside it. You can see remotely this GPS is there, which gives the locations. So we gather this information about the variability, spatial and temporal. There is a data processing and analyzing to assess the significance of that variability. Then we develop the models, and then we give the prescriptions, and we give the management strategies for variable rate technologies. So these are the various scenarios and strategies that can be used for precision farming technologies. So you can see behind these tractors are mobile vehicles. So these are the mobile robots basically. Okay, in these mobile robots, these technologies are connected to the backside of the tractor, and then they work. And you another scenario here, there is a real-time scenario in figure A. You can apply in real time. In scenario B, there is a map-based scenario, and C is the integrated approach, in which real-time and map-based both are. You can see that in real time it is applying the inputs through this sprayer, which is connected to the front of the vehicle, mobile vehicle. And in fourth scenario is a wireless sensor network completely, which is embedded or spread across the fields, and that governs that management system. So agronomic variability mapping, here all this embedded system is sitting inside it, and it is controlling the whole pneumatic operations or sensor operations, receiving out the GPS signals or remotely sense images, etc., and then governing the applications here in the field. So these pictures you are seeing here of the developed countries, what you are seeing at the top of this is that we have developed at our CSIR lab Indian fields, and the top of this you are seeing the embedded system that is attached here, and here are the electrodes. So what happens is that through these precision farming technologies, you can apply right inputs at right amount, at right time, at right place, and using the right technology. That is what this optimal variable input rate application technology is. And you can see that how these vehicles look like, how they apply these all. And this is the whole thing, scenario sensor based, cloud based, cloud computing is also there. And you see how the whole things are applied here. Big machines are there. In our country, we can replace it with the man. We don't have machines, but we have manpower, a lot of manpower, because US kind of countries are there, almost half of the population that we have. So the evolving farming technologies today are basically, if I compare, today they are electrical and mechanical, but tomorrow they are going to be information based. Today's technologies are hardware oriented, but tomorrow's technologies are going to be software oriented. Today's technologies are manual and on-site control, and tomorrow's technologies are going to be completely automatic and remote control. By sitting in your home or office, you will be able to record the data and take care of that. And today's machines are independent and dumb machines. I mean, there is lack of smartness in these machines. But tomorrow's machines are going to be networked and smart machines. Like we are going to come up with the smart cities. So they are going to be networked and smart machines taking care of the farming operations. User and environment demanding. And tomorrow's machines are going to be user and environment friendly. So unpredictable quality and quantity in today's machines, there will be a predictability of the quality and quantity. We'll be knowing that how much is happening. So you can see the picture here, the smart vehicle which is used, the human machine interface connected here that you are seeing actually is so sophisticated. It is as if you are sitting in an aeroplane, in a fighter aircraft kind of thing. All the gadgets are there. And don't think this is any fiction story that I'm showing. This is actually happening in developed countries, and in our country scenario is changing. Earlier we used to use some tractors just with the open tractors. Now you are seeing the air conditioned cabinets already started coming in. So there is a shift. People have started using the laser land levelers in Punjab region at least. So it is saving upon a lot of productivity. Water conservation is happening with that technology here. And earlier there was a lot of resistance to that technology. So it is entering, but the pace is very slow. You can see big poly houses, how controlled way they are developing this. Because the irony of the thing is, what we eat and what for all we are doing this work, or we do jobs and etc. But what we eat, that we are buying from a market which is so filthy. Sabji mandi. सब्जी मंडी में क्या होता है, इट इज सो फिल्दी दैट लॉट ऑफ डस्ट एंड एक्सेट्रा, एंड वहां पर आपकी सब्जी रखी हुई है एंड यू आर बाइंग इट एंड यू आर कंज्यूमिंग इट. So we have to take care of the aspects which are most concerned to us, and controlled irrigation and spraying. You can see how they're doing it. It is all automation and embedded systems which are inside it. And you see these big robots, robotic sprayers that they're using it. These technologies are using. And you see the cloud farming. The cloud has entered already the farming, etc. There is a store, there is a local SMS, cloud FMS. All these networks are connected together. And look at these big machines which are working in the farm fields, and therefore their production is also good. Look at this again, big machines, robotic machines, lot of embedded system is inside this, and very powerful processors are there. Very, very powerful machines. These are the examples, the slides I am showing, how they are plucking, they are planting, plucking. Most of the things are happening with the machines now. Okay. So this thing like harvesting also, while harvesting they are recording everything, how much is being harvested, and so many things related to it, the recording. So the technology that we developed at our lab is actually tractor mounted mapper. We filed a patent on this. We are the second after USA to file a patent on this technology. The whole area as such, precision farming area, is just 20-30 years old. So one thing is the area is just very recent. For last 20-30 years people have been working precision farming practices like organic farming, etc. And developing a technology to guide the farmers to do the precision farming is again another new thing and very innovative thing. So in that again very less research is happening. For example, this tractor mounted mapper which can map the soil. So this is the technology that we developed, and you can see that just behind the tractor with your existing accessory you can connect this gadget, and the cost will be almost less than 1 lakh rupees, whereas the imported cost is more than 20 lakhs, 25 lakhs, even 50 lakhs. This technology that you are seeing, are you able to see the video? I hope you are able to see the video. You can see these electrodes, they are just slightly touching the ground, but then they are able to map the soil surfaces as below as 3 feet. Below 3 feet area, they are able to record the profile characteristics of the whole field, and as a result you can then precisely know that what is the soil conditions, what is the characteristics and the profile of the soils, temporal variations and the factors affecting the crop, and then you can optimally make decision that how much should be applied, the nutrients and manuring, irrigation, etc., and where we should be applying. Because what you are seeing here is the embed system. We have used the PIC 32, PIC 16 controller earlier, and now we have migrated to PIC 32 family, this tractor mounted soil, this embed system that you are seeing, and we are now enhancing, upgrading it to the human machine interface, which is touch based. So in real time it will show to the tractor operator that what all is happening in the field, and he will be able to locate and trace the whole things, the health of his soil. You can see these electrodes are just slightly touching 1 to 2 inch, but they are able to map the whole soil profiles up to 3 feet below the ground. And there is a GPS attached to this internally, okay, which just costs 5,000 rupees, which is the research cost. When it comes to the production cost, I am sure it will come down to 2-3,000 rupees. This GPS locates, gives the geographical locations, coordinates of the properties of the soil, like nutrient, fertility attributes, and so there is a geographical coordinates. And what happens at the end of the day, then you can, and we are now also upgrading this to wireless sensor networks and internet of the things, so that on mobiles only you can have app, and therein you can get the complete health of your fields. So few of my students, doctoral students, are working on this program now for the upgradations. This was the program that we developed in the 11th 5-year plan during 2007 to 2012, and the trials were conducted at Punjab Agriculture University. The whole machine is automated machine. There is an inbuilt that robotic and pneumatic system mechanism of the tractor, which has been used for lowering or raising the depth of the electrodes, and rest all is taken care by that embed system. There is automatic injection of the signals in these electrodes. What you are seeing, the coulters are actually, there is injection of the signals in these coulters. 2 coulters inject the injection currents signals, and the other 2 they receive the signals back. And this array that you saw was a specially designed array. Okay, this is the comparison with the imported system, and we are cost effective and better in terms of innovation. These are the trials which we conducted at Punjab Agriculture University, and this is a specially designed array, and the whole, this is a complete mechatronic system, you can say. And finally, this kind of maps you can get once you input this data to the geographical information system, and that can help you to derive a lot of agronomic decision makings. And this is the certificate that we received from Punjab Agriculture University. This is the recognition at international level from Professor David Mullah from University of Minnesota, who recognized my expertise in this area, and he was key. I mean, we were very keen to work jointly in this area. So this is the whole embed system inside, which uses this mixed signal controller from PIC. And earlier it was 16-bit, now it is getting upgraded to 32-bit. There is a memory to it, there is a GPS, and there is a specially designed array, current injection system, switching matrix, human machine interface, and this programmable constant current source is there inside it. And this is the whole diagram, which includes GPS, programmable source, switching matrix, memory, human machine interface, and specially designed array. This is the whole inside of the electronics that we developed. You can see this is a complete PIC based design. A lot of circuits, I think you just take a look at it. I mean, you don't have to understand it completely, but these are all the insights. PIC 24 FJ128 was the series of 16-bit that we used, and now we are migrating to PIC 32 and PIC DSP kind of processors, which is undergoing. So far we have finished, I think, almost 50% part of it. Remaining 50% is envisaged to be complete by March for this upgradation. So these are all the diagrams of this, and thank you for your patience at the end of this, and I hope you enjoyed this. I have many things to talk about, a lot of other technologies we developed, like for water sustainability also we developed such a real-time gadgets which can monitor the rivers in real time and upload the informations. That project is presently ongoing, which can monitor the real-time fashion the rivers, how they are, like your Ganga river contaminated a lot. So in real time it will be able to monitor and upgrade the information through IoT and wireless networks to the controlling authorities. So that is going on. Then we also are working on food sustainability technologies, some more post-harvesting technologies for monitoring the security, safety aspects of the technology using some hyperspectral imaging cameras. And in everything, we are using all this embedded system finally for deploying these field usable systems, because while we deploy these systems to the fields, we need the miniaturization, cost effectiveness, space effectiveness, power effectiveness, etc., etc., and wherein we definitely we need then this embed systems. So all of you must, I hope, might have enjoyed this. And although I am having a lot of more stuff to show you or demonstrate you, I was carrying my MP Lab softwares also and some Proteus simulations also, but it seems that time will not permit me to do that. The field is very vast, but I think the intention of this all talk was to sensitize you in the area and maybe to create in you some research interest. I think that was the main objective of the today's talk of industrial application, to create some research interest in you, so that you may would like to take up them as a research assignments, as a problem statements in your doctoral or MTech thesis studies. So from my side, you all are welcome to join me in this endeavor, and anything that you like to do in the areas of embedded system, artificial intelligence, or wireless sensor networks. So I will look forward and welcome you to work in this area. And any queries if you have, because the coordinator of the course, Dr. Kanika, is already here to wind up the session. I think so, because I can see her here available, and as far as I am aware, the session was scheduled from 9 to 11 or something like that. So you may go ahead for the queries if you have any on what you have seen and anything you would like to interact with me on that matter.
Yes, queries from from nodal centers, participants who are sitting at nodal centers. PVP Siddhartha. Yes, ma'am. Do you have any query?
Yeah, good morning, madam.
I'm missing you.
Good morning, sir.
Good morning, ma'am.
Nice to see you once again today.
So nice of you. Same here.
Thank you, sir. And you have already given the information regarding the application-oriented information about the embedded systems.
Yes, ma'am.
Very fine, sir. Though we are having one small doubt. That is, we are at most using pesticides for developing our food crops, right, sir? So,
Yes.
what are the necessary measurements to be taken for the food crops without using the pesticide? How can we develop the food crops without using pesticides?
Yeah, very good questions, and it seems that my presentation sensitized you to the extent to put the right question forward, and it gives me satisfaction that it served the purpose. So now coming back to your query, I think the organic farming already talks about doing something which is pesticide free, chemicalized free. So what they are doing is actually they are using the natural practices or natural ways of getting rid of pests and etc. But you see, there is always, there are different schools of thoughts wherein organic farming only will not, I think, probably suffice the food sufficiency or food reliance, because organic farming may the in 1 acre area, let's say your traditional farming, if is producing 15 tons, that produces very less as of now. But there are farmers who have also demonstrated that they can equally produce at par with the conventional farming. So that is another side of the story. So of course, organic farming talks about doing everything without applying the pesticides, like we can do our kitchen gardening also with our normal fertilization like cow dungs, etc. And then you can use those neem and etc. But as far as the precision farming is concerned, I think the point is, if you do anything excess of everything is very bad. So I think the precision farming talks about optimally applying these inputs and nutrient application. So therefore, if we the way I showed, that spatial and temporal variation is nicely mapped, because right now just with the simple naked eyes our farmers cannot make out that what is there in our soil or what is there required to the crops. So what we need is the technology. The technology, like you see, X-ray, we cannot see with the naked eye what happened to our bones, but X-ray has that power,
Yes.
okay, which goes below and tells you what is the defect, what is the problem. So the technology has that power which can tell you how much it is required and where it is required. So optimization, applying the pesticide is not bad, but doing it in excess is actually something which is bad. So the one of the technology which I talked about, madam, is actually maps the various things spatially and temporally. And then there are, in my own lab only, one of my colleague developed a pesticide sprayer. Okay, he developed a sprayer, pesticide applicator, which uses some charge based theorems or principle. So it applies exactly to the leaf or to the plant, and it will not allow the pesticide to go in the environment. Okay, it is a very optimal application of the pesticide to the place where it is required. So applying pesticides or applying nutrients is not bad, but doing it in excess is actually bad, and that is what these technologies like precision farming is talking about. So if we use this kind of technology, then I think we'll be able in a position to apply the right inputs, including nutrients, including pesticides, and if we do that in optimal manner, then we can have good results. It is like, madam, we have Ayurveda, okay, we have homeopathy, we have allopathy. So allopathy में आपको पता है कि वो देते हैं सब आपको मेडिसिन मिल रहा है, ठीक है, है ना, केमिकल कॉम्पोजिशंस में है, एंटीबॉडीज है, ठीक है, एंटीबायोटिक्स जिसको हम बोल रहे हैं, कि उसको रूट कॉज के ऊपर नहीं वो एक्ट करता, वो क्या करता है, उसको दबा देता है, सप्रेस कर देता है एंटीबॉडीज. वेयर एज अवर आयुर्वेदा टॉक्स treats the cause, homeopathy talks about treating the cause. और आई एम स्टिल वंडरिंग इन विच ईरा वी आर लिविंग. देयर वाज अ टाइम जहाँ पर एक वैद्य जी होते थे गांव में और सब लोगों को कोई बीमारी नहीं होती थी, और आजकल स्पेशलिस्ट हॉस्पिटल बने हुए हैं, इतनी लंबी लंबी चौड़े क्यू लगी हुई है हॉस्पिटल्स में, लोगों का नंबर नहीं आता, लोगों को रेफरेंसेस देने पड़ते हैं. तो आई थिंक तब क्या था, आई डोंट नो, पोल्यूशन भी नहीं था, एक वैद्य जी पूरे गांव को ट्रीट कर सकते थे. आज इतने सारे डॉक्टर्स, इतने सारे मेडिकल यूनिवर्सिटीज खुली हुई है, हॉस्पिटल्स खुले हुए हैं, लेकिन फिर भी लोगों के पास प्रॉब्लम ही बहुत ज्यादा है. I don't know what is happening. Are we advancing or what is happening? Or
again.
Yes. So basically यही है कि अब उसमें भी जैसे आयुर्वेदा और वो था, जैसे मैं बात कर रहा, तो इसमें भी आपको ऑर्गेनिक फार्मिंग भी है, तो एलोपैथी कह लो, तो इसमें प्रिसिजन फार्मिंग है, जिसमें आपको ऑप्टिमली करोगे with all that technologies, then I think there is no side effect.
Okay, sir. Thank you, sir. Once again, giving a wonderful lecture to all our student faculty members.
Thanks a lot, and the audience like you boost my moral and my confidence and my motivation in delivering the lecture. Every time, I have been doing it from last 5-10 years, but every time I come with the preparation. Yesterday also I was till 12 o'clock or 1 o'clock, I was in the lab in the night preparing for this all, and if I can add more and more. So every time I come with the preparation, but time always, comes as a impediment to inform you less. Also I prepared lot of videos are also there, but time will not permit me. मेरे पास videos भी काफी लाया था, और मैं माइक्रोचिप, एमपी लैब एटमॉस्फेयर में कैसे काम करना है, प्रोटीएस में कैसे काम करना है, सिमुलेट कैसे करना है, वो सबका वीडियो भी था, और कुछ थोड़े से एग्जाम्पल भी थे.
You can share your email ID and
Yeah.
the details
Yes.
if they have any query.
Sir, in future, again, if we have any provision to have the same STCs in our college by the permission of NICCC at Chandigarh, please, sir, we expect again the same sessions from you.
Yeah.
Thank you, sir, and wish you all the best.
Yeah, thank you, and probably I would also advise or suggest कि next time if there can be some session on C programming or embedded C for PIC kind of sessions, wherein I can give some hands-on how to write the embedded C programs for PIC controllers or something like that, along with some good examples. So that will be.
So for such kind of programs, all the participants have to come in this our institute. So that type of programs can also can only be possible only in contact mode.
Yeah, hands-on
So
training,
it's
learning
not
kind
possible
of.
during this ICT based course that we can transmit all the contents that of related to programming only.
Yes,
Right?
Yeah, one hands-on workshop can be conducted. I think
Yes.
we have limitations in terms of this kind of contact programs. So there can be now direct contact programs in which we can have hands-on training workshop, wherein I'll be very happy to deliver very wonderful talk in terms of all those hands-on.
Yes, ma'am, definitely, if time permits and anything permits, definitely you plan, ma'am, in future to conduct these type of hands-on sessions to all our faculty members.
Yes, actually we are planning and we have conducted such type of courses, but that type of courses are possible only in the contact mode. They are not possible that we can conduct such programs during this ICT based courses.
Okay, ma'am.
So for that, you have to come in our institute.
Sure, ma'am, definitely. Thank you, ma'am.
Thank you. Thank
Thank
you.
you, sir.
Thank you very much,
So
ma'am.
queries from other participants, other nodal centers, JCRC, Jaipur.
Hello.
Hello.
Uh, I'm from RD Engineering College.
Yes, yes.
Sir, you told us about some sort of array you use in a tractor for sprinkling the preservation of farm. For mapping technique, you told us something about mapping technique. I want to know what type of sensor you use in that.
Yeah, that specially designed array we are talking about, specially designed array that we saw in the movie, that video. Is it
Hello.
that? It,
Yeah.
yeah, sensor array, sensor array, which is actually the mapping the surfaces, specially designed
Yeah.
array that you're talking about, right?
Yes. Yes.
Yes.
They are
Yeah.
actually interested in knowing the
Yeah.
type
Knowing
of
the yes
sensor.
type of
Yes.
sensor. The type of sensor that we use in this case was a contact type. Although now we are also working on non-contact type. The contact type sensor that we use basically worked on the Venner array and Schlumberger array principles, which actually uses the impedances or the resistance measurements of the fields, and which actually relate it to the soil composition, sand, silt and clay, water holding capacity, nutrient holding capacity. So those different array principles, we made it a specially designed array. Knowing the Venner array is nothing new, but we combine this Venner array, Schlumberger array, dipole-dipole array, and inverse Schlumberger array. All those combinations we combined, and we created a special design array in which, just by using the 7 electrodes, we are able to get the inside about the inside about 30 centimeter, 50 centimeter, 60 centimeter. We can always almost go scanning every data layer of the soil horizontally and horizontally in different planes. We can scan different layers of the fields using this kind of principles, which has got that kind of uh, sounding depth principles abilities. So that is what the principle is, and we are using some particular source through which we are doing the switching of the signals to different pair of the arrays, and it gives the information, because the the electric fields, they are hemispherical in nature, spherical in nature. Those fields, they travel in spherical in nature, and then they take the information about the whole volume of the soil. That is what the principle is, actually how it works. So they capture the whole volumetric information using those spherical fields, and then that is being measured by another pair of the electrodes. That is what the principle is all about, and that is what this patent is all about, that we have secured or we have applied for. So that is the principle that it applies. Yes.
Okay. Thank you, sir. Thank you, sir.
Yeah, and just for your additional information, we have many other technologies to do that job. Like we do spatial mapping through aerial images, also like through satellites, remotely sensed satellites imageries can be taken, bare soil imageries. We can also have, one of my now doctoral student is working on unmanned aerial vehicle UAV, in which he's deploying the hyperspectral imaging camera, in through which he is capturing the images of the soil. He will be doing that job, or even the crop canopies, and through that he will apply a lot of artificial intelligence techniques and algorithms for driving the feature extractions, that what is the all profile of the crop health and the soil health, and then again giving the prescriptions, decision support systems. So there are a lot of technologies. So optical technology, electrical technology, ion selective technologies, there are different ways of doing it.
Okay. Thank you, sir.
Yeah, if you find any further interest in knowing about it more, or doing any research in this area more, my details are displayed over here in my slide. You may please contact me, and I'll be happy to answer you on anything on that.
Okay. Okay.
Yes. Queries from other centers. From RD Engineering College. Is your query answered?
Yes, ma'am.
Okay. Thank you.